Our next speaker is from Poland. His name is Mariusz Gil, and he is an architect and CTO, and he's focused on performance and scalable web applications. And because of that, he will be talking about discovering graph structures, graph databases, stuff like that. One of my favorite topics within the last few years. So he has been working for several companies on PHP projects for millions of active users, from biggest social network and instant messaging software in Poland to multi-billion PV content, personalization and delivery platform. Mariusz is also a member of 4 developers and PHPcon Programme Committee and one of the core members of PHPers. He also takes part in meetups for PHP developers in many cities in Poland. And after hours, he is a mountain biker and also a rock guitarist. So welcome him.
Hello everyone. Thanks for a pretty nice introduction, thank you. First of all, I would like to congratulate to all people behind this conference for making it possible. It's impressive, congratulations. Today, I would like to talk with you about discovering graph structures, about some techniques, some tools, some servers you can use to power your PHP application. But before we started, I would like to tell you something about more for me. I live in Poland, in Wrocław. This is a quite nice city located in Lower Silesia region. Sometimes my city is called Venice of the North because we have got a lot of cities, over 120 or something like that. I'm a professional developer since 2000, so yeah, I'm pretty old, I think. During this time, I was working as a PHP developer, PHP tech lead, PHP architect, web architect, consultant, trainer, and many other positions. But in at least 2 very interesting companies. One of them was Nasza Klasa. Nasza Klasa was the biggest Polish social network before Facebook in Poland. We've got PHP application running over 600 servers. So I think it's quite impressive. And after all, and maybe this is more important for me, I'm also a co-founder and one of the members behind PHPers community in Poland. PHPers community is the biggest community for PHP developers in my country. We've got meetups in, I think, most of important cities in our land. So this talk is not about giving you right directions, right solutions. Instead of this, I would like to inspire you and make each one of you to dig this topic on your own. Because I believe that inspiration is much better than solutions. So let's start. This talk is all about data. Why? Because in many cases, almost over, this is the most crucial thing in our application. Without data, our application doesn't work. We haven't users are unhappy. So we need to focus, when we are thinking about data, we need to focus at least on 2 aspects: about storing data, how we should store our maybe megabytes, maybe gigabytes, maybe petabytes of data. And the second aspect, how we can process this data. Of course, this is much harder. During my consultancy work, during, I don't know, 5+ years or something like that, I noticed that almost over, let's say in 90% or more of web apps suffer because data storage, data layer performs very poorly. So the question is, why? Why does this happen? So let me share you my 90+ hypothesis. It will be written in some kind of scientific notation. Maybe you are familiar with that. So the hypothesis is like that. For every developer in developer set, there is no such a data structure which couldn't be represented in SQL. Think about it for a while. Why this is true? Because we all speak SQL. Maybe you are PHP developer, maybe you are a Python developer, maybe you are a Java developer, but we all know SQL. This is our native way to work with data, to represent this data, to process, transform, and many other things. So it's sometimes this is a problem because we want to transform every possible data structure to something we can put into RDBMS system. Sometimes it leads to 7 megabytes queries. I saw it. Believe or not, but it wasn't the biggest query in this application. And of course, this is wrong. This is really wrong. Why? The developer which created this query was too much focused on storing data and forgetting about this, oh, by the way, this is a speaker stress tool. So forgive me my mistakes, I'm under heavy pressure. Okay, the developers sorry. The developer which created this multi-megabyte query was focused too much on storing data. So there's also extended version of my 90+ hypothesis, which is that for every developers, there is no such structure like set, tree, graph, or list, which couldn't be represented in SQL even with JSON event format. Of course, we need many different data structures. It's obvious. For example, when you are working on, let's say, e-commerce application, like something similar to eBay, we need to use different data structures. For example, let's take it almost invisible. It's breadcrumbs, categories. It seems to be a part of the category tree, so the tree, the first data structure in this screen. The second, the recently viewed box. It seems to be a list, yeah. The list of recently viewed items per user. This data structure, it shouldn't be big. There's, I don't know, 1,000, 2,000 categories in e-commerce websites, something like that. But the second list, it should be bigger. Bigger in every day. Of course, we can implement almost all data structures in typical RDBMS system, like MySQL or Postgres or SQLite, whatever. For some reasons, it will be okay. So when we ask, let's say, Google about it, we will get thousands or even millions pretty nice solutions. For example, how to implement linked list in MySQL, yeah? Or how to implement tree structure in MySQL. Some of them are pretty nice. I believe that you are familiar with storing lists or trees in a typical RDBMS system. But sometimes we need to find the best possible solution. For example, where we are storing the tree, the typical naive implementation contains node ID and parent node ID. That's right? Are you agree? Yeah. Okay, so storing aspect is okay. But what about processing? What kind of query we can execute on this structure in this design, in this data table design? We can get all the nodes just select star from table. We get all the nodes, yeah. We can get all the childs single level deep for every single node. But is it possible to get very effectively all the subtree from given node? Let's say stress. Let's say we want to get all the childs for this node. It means all of this tree. The answer is no, because there is no effective way to get this node, because this parent ID is configured to this. So we need to join or generate multiple select queries. It took time, of course. There's a pretty nice presentation called Models for Hierarchical Data. This presentation is 5 years old, but this knowledge is still actual. So I recommend you to find this slide share, Models for Hierarchical Data, and read slide by slide, from slide 1 to slide 91, I think. This is all about how to store hierarchical data like trees in typical DBMS system. Okay, but trees, lists, sets are pretty easy structures. For some of them, we can use Redis. Redis is a powerful tool. I use it for years. It helps me a lot. For sets, for lists, it's magic. But there are many other data structures which couldn't be represented in SQL or Redis very effectively. For example, graphs. Graphs are, by the way, pretty old data structure. Maybe you know that the first scientific white papers is dated on 1766. This is a work Euler about bridges in city called Königsberg. So it was quite a long time ago. So, but what the graphs are? From mathematical point of view, graphs are the non-empty sets of vertices connected by edges. That's all. That's all theory. So, in this example, we've got node A, node B, node C, and edges. A is connected to B, B is connected to A, B is connected to C, C is connected to B, and A is connected to C, and C is connected to A. That's all. By the way, this is a special graph. This is a special graph called complete K3. So, what is complete graph? Complete graph is a graph where all nodes are connected to each other. This example, complete graph called K4. Before there are 4 nodes. Every node is connected with each other. Sometimes we have dense graphs. Dense graphs are the graphs where most of nodes are connected with each other. And finally, we've got sparse graph. Sparse graph is the graph where only small subset of nodes is connected with each other. What is the difference between dense spar and sparse graph? The main difference between those graphs is about the amount of memory we need to store the representation of this graph. For example, for dense graph, probably the best solution will be the adjacency matrix, and the sparse graph will be presented better in the adjacency lists. Okay. This graph, and this graph are examples of undirected graphs. Undirected. But we've got sometimes graphs with directed edges. Directed graphs, called sometimes D-graphs, are the graphs where vertices are connected to each other by directed edges. So the node A is connected to node B, but node B is not connected to I. This is a very important thing. And B is connected to C, but C is not connected to B, and C is connected to A, and A is not connected to C. And the last part of this theory introductory is about properties. Vertices and edges can contain properties, 1, 2, or whatever you want. So, we've got node A, let's say its property type person, property name, Jon Snow. I think you know it. Vertex B, type nothing. So what is the relation between them? Type knows. So Jon Snow knows nothing. Graphs are almost all about data visualization, are very handy, very useful technique to visualize your data. And it's a very, very simple example. Math is math, life is life. You can love math, you can hate math, I don't know what you prefer. But what about graphs in your real life? The question is, did you see and did you saw any graphs today or tomorrow or yesterday? What do you think? Yes? Yeah. Thanks for that. On every t-shirt here is the graph. This is the one graph, and lion is another. So, by the way, this is an example of graphs with cycles. There are a lot of cycles here, for example, here, here, and so on. Yeah, we are surrounded by graphs, believe me. I'm going to bet with you that you know this graph. But okay, without labels, it could be very hard to recognize. Who knows what is this? Almost close. It's a Jira workflow. You are using this almost, I think, almost every day in your work. Yeah? You agree? I think yes. So, this graph represents something. Do you know what this structure, the object behind this is? This is a finite state machine. Are you familiar with finite state machine? Yeah. Computer science studies? I think yes. Okay, so we are not talking about finite state machine, but finite state machine are very useful, and I will show you at next slides how you use FSM in your PHP application. So one of the properties of finite state machine is that this finite state machine can be in one state in the moment. For example, task could have state in progress, or be resolved, or be closed, but never be in two states together at the same time. So we can represent this data in, I don't know, MySQL in this way. Yeah, task ID, task status, labels translated to the integers or something like that. I think that a lot of you are using the status field for the objects in database, right? Yeah. So the question is, how can we handle this kind of data in application layer? There is a very small and very useful library called Finit, available on GitHub, on Packagist, whatever, which allow you to enable infinite state machine for your models, for your data, for your everything you want. The first step you should do is just implement stateful interface in your model. Just copy-paste from documentation. No rocket science here. Or put this code in trait and use traits in your models. The second step is about configuring the states. So we got states S1, S2, S3, S4. Some of them are initial state. Some of them is final. And the last one, we can define transition between states to get this picture. Sorry for that. And then finally, connect our state machine to our model. We've got 4 transitions here, S1 to S2, S2 to S3, transition, yeah, S1 to S2, S2 to S3, S3 to S4, and finally S4 to S2. This is the graph behind this finite state machine. After that, we can ask the state machine for something. For example, is transition T4? T4 is between S3 and S4? Doable? The answer is yes. Is transition T12? Oh, let's say, is transition from 2 to 1 doable? No. The example how we use it. We had application with hundreds of thousand objects in database where 100 transitions were defined between tens of models, and after all, and more important, we had one action, one single controller with single action to control all the transitions. This, for me, is a pure implementation of dry rule. Do not repeat yourself. The code was very similar to this. It was Symfony application, so all the logic was executed here. Is given transition doable in this specific model? Yes or no? Yes, okay, do it and save it. No, generate exception. Single file, single controller, single action, tens of models. Okay. Next one, this graph. Very similar to this one, I think. What is it? Okay, so this K vertex with no edges is called isolated vertex, isolated node. What is it? Oh. Okay. It's a Sophia. Seriously, it's a subgraph of streets in Sofia. This is a Sofia rail station. This is a Sofia house. Excellent. Edges are streets, and times are about the time you need to take from this point to this point, on this point to this point. This is very useful, very useful. Why? Because this graph can answer for some kind of questions for us. For example, what is the best way to get from here to here? Maybe this way, maybe this way, or maybe this way. There are many graph algorithms for searching the shortest path. One of them is a Dijkstra algorithm. Dijkstra algorithm is about searching the shortest path between nodes inside the graphs where edges are non-negative. So, and the last example, maybe even more real, it's a subpart of Twitter. Let's say we've got 3 users, Tom, John, and Bob. Some of them are follow. John follows Tom, John follows Bob, Bob follows John. All of them are interested in the hashtag PHP. John and Bob are interested in web hashtag. Tom tweeted about something, and John retweeted. Yeah. And after all, Tom is interested in hashtag JS. This graph is currently buzz in United States, in Silicon Valley. Why? Any ideas why? Because this is all about recommendation. Graphs are very useful for building recommendations engines. I'm looking at this graph and I can say you that John is interested in JavaScript. Why? Let's say their nodes are not connected, but Tom is connected to JavaScript, Tom is connected to PHP, Tom tweet about X, John retweeted. John is connected to PHP as well as Tom. Tom is connected to web as well as Tom. So the difference is here. There are many interesting algorithms called collaborative filterings, which can use the graphs and create some predictions that John is probably interested in JavaScript. I spent 4 years in Warsaw developing a recommendation engine, so believe me. Okay, how we can store and execute some algorithms against the graphs in PHP. There's pretty nice sets of libraries for processing graph called graph or graph PHP, whatever. There are separated library for graph defining. This is an example how graph could be defined here. Just create vertex, create edges, and that's all. There is a dedicated library for graph rendering using GraphViz. And there's also sets of algorithms you can use against those graphs, like searching for shortest paths, searching on spanning trees, or traveling salesman program solutions. And the DX algorithm is already implemented here, of course. Of course, you can use, of course, SQL for storing the data and load this data into memory and use this library. For example, this typical, very naive approach for directed graphs and typical naive approach for directed graphs with weights. If you are interested in storing graphs in SQL, there is a fantastic blog post from Invika Tech Portal about storing the graphs in database in social network context. By the way, this post is 6 years old, 6 years, and the knowledge is still actual. So, as you see, there are many different solutions for small graph, medium graphs, large graphs. I would like to show you something even more interesting. Neo4j. Are you familiar with Neo4j? Yeah, okay, great. If you are not familiar with that, no worry. All you need is follow just 3 simple steps. First, of course, install. If you are using the Linux, it's very obvious, very typical approach using apt. No rocket science here. If you are a Mac user, Windows user, just download the package, run the server, that's all. Of course, this is single node solution, single node setup without high availability, high scalability, and things like that. If you don't want to run Neo4j locally, don't worry. There are the dedicated solutions for running hosted services like GraphStory. Just log in and load your data and get the results. So the second step is run. When you run Neo4j, you can access the beautiful web interface, web UI, directly on your browser. You can run your query, you can browse your graphs this way. And the last steps, just write the query. Neo4j came from JVM world, so it's a Java. I don't like it, to be honest. And for JVM languages like Java or Scala, there's a native protocol to talk with Neo4j servers. For other languages like Python, C#, PHP, of course, the communication is done via HTTP and RESTful interfaces, of course. So for PHP, we've got brilliant library called Neo4j Neo Client. You can do almost everything with Neo4j just through your PHP application. So I would like to show you something in real time. Okay. Maybe this would be better. By the way, do you know what the main speaker rule about giving live demos is? Do not. Okay, and why? Because everything can happen. Okay, so this is our console. This is the database is empty. There are no nodes here, so we can simply. Where is the cursor? Okay, here. Let's say create vertex n type person with some data. Let's name Luke. Yep. Everything okay? Seems to be okay. Okay, query was added. So how it looks like? We've got the single node. Okay. So create another node with label person, with name, let's say Leia, and age. Of course, you can define the relationships between the nodes. We've got not so much time, so I've got prepared code in PHP, so I create some nodes from PHP application and show you something to speed up. Okay, our database is clear. Okay. Data was created. We've got 5 nodes labeled with person label, Luke, Leia, Vader, and Obi-Wan, and 2 nodes labeled with robot, C3PO, and R2D2. They are not connected, as you see. So let's run a query, which is that. Find Vader, find everyone who is not named Vader, and create the vertex, create relationship, between them with label won't kill. Okay, so let's run it. Yeah, okay. So this console is very pretty, so we get something like that. Whoa! Okay, so at this moment, Vader wants to kill everyone. So let's add some other relationship. For example, this one. Okay. Create relationships called father between Vader and nodes called Luke and Leia. Just run it. Okay. As you see, between Vader and Leia, there are 2 relationships. One called father, and second, won't kill. Okay. Let's add some other relationship here. For example, make a look owners of all robots here. Okay. Sorry? Something was wrong. Okay. Okay. So, let's make Vader the master of Obi-Wan. Yeah, and finally, make Obi-Wan master of the log. So how our graphs looks like. Yeah, it's something like that. The node look is owner of 2 robots. Vader wants to kill everybody. And the Vader is father of Leia and Luke. So we can visualize this data this way, but of course we can access this data, ask some queries, some aggregation. For example, we can get Vader nodes and get all the connected nodes, or the connected node with given length, or something like that. For example, we want to know how many robots is owned by each user. Well, for example, yeah, the result is not a graph, the result is typical SQL result. We can search our graphs for relations with some constraints, okay? Give me the all nodes which are connected by relation won't kill. Give me all nodes with relationships owner where the date is since, for example, 2011 or something like that. We can also run some built-in computations, built-in algorithms across against this graph. This language is called Cypher. This is a SQL language, SQL-like language for accessing the data inside Neo4j. From PHP application, this looks very easy. Just get nodes for nodes iteration, just access the property of node, the label of the nodes, connected nodes for every single node, and things like that. Documentation of this library is fantastic, always up to date, so you can use it. So, if you want to dig in this topic, this is the book I recommend you. The first one, Graph Databases, is available under graphdatabases.com and is absolutely for free. You can download this in PDF format. There's a second edition of this book with PHP Neo4j supplement. So all you need is download and learn. If you will be familiar with some Neo4j concept, you can just learn some advanced structure in Cypher. Neo4j isn't the only database for graph processing. There are many, many others. For example, Infinity Graph, OrientDB, the multimodal database, or ArrangeDB, the multimodal NoSQL database. Most of them are highly scalable, highly available, ACID transaction compliant, and things like that. You can find even more NoSQL databases, graph databases, under the website nosql-database.org, where almost all 225 NoSQL databases are listed and described. So, but you have to remember that the tools will change. Tools will change today, tomorrow, maybe next year, but ideas like algorithms and something like that are almost immortal. So we are still using the Euler graph concept since over 200 years. So the question, I think we are out of time already. So let's make short QA and question-answer session, but in reverse. I've got a prize for the fastest person who answered the question. And the question is, maybe hand you So, the question is about the Dijkstra algorithm. Yeah? Congratulations. You can reach me on Twitter, Mariusz Gil, just like my last name and first name. Ping me anytime you want. Write my talk, and thank you very much.